Today I will be discussing about the centripetal force. Now, what do you understand by the term centripetal force? Centripetal force is the force that is acting on a body which is moving in a circular path such that the force is always pointing towards the center of that circular path. So, it is the force Now, if there are many forces acting on a body, then in that case, the centripetal force is nothing but the resultant of all the forces if that if there are many forces acting on a body which is moving in the circular path, then in that case the centripetal force is nothing but the resultant of all the forces acting towards the center. Say for example, a body is this one which is moving in this circular path. Now this circular path can be of any radius, or at any particular instant there might be a circle that can be generated if you trace that arc covered by this object at a particular instant. What does that mean is, if this object that is moving in this circular path has traced a small elemental distance, okay, say for example this is ds at a particular instant, then you can draw a circle that is covering this arc and has a center at this point. Now the centripetal force will be acting in this object which will be pointing towards this center. Now say for example, at this particular instant, at this point, the velocity of this object is pointing in this direction. It is tangent to this circle, that is v1, and at this point, and after it has moved by some certain angle, just d theta, its velocity is pointing in this direction, v2. So this velocity and this velocity has this change in velocity. You can take a vector concept in this situation, and the angle that is traced is d theta. Also, the radius vector, that is r1, is pointing in this direction in this situation, and it is pointing in this direction in this situation. This both has same magnitude, but the direction of these two radius vector is different. Okay, so you can also use this here. This is r1 and this is r2, and this is change in r. Now if you see these two triangle, then these two triangles are similar, okay, because this angle theta is equal to this angle. Also this distance that is covered by both this vector is same. This is equal to this. So two conditions to satisfy the condition of similarity of a triangle has been fulfilled. So we can use the concept of similarity of triangle in this situation. So if you see, then the sides are proportional. So opposite to this side is change in V, and opposite to this side is change in R. And you can take any one after this. That is, if I take this V1, these are all the vectors. So V1 and this is R1. As I said, these quantities I have written here are vector quantities, okay. So in similarity of triangle, if we only take the magnitude of this vector quantity, then this is change in V, okay. These are all vectors. This is all vector quantities. So change in V is the magnitude for this one, and change in R is the magnitude for this one. So if we take V1, the magnitude of this velocity as V, and magnitude of this as R, then this is the result, okay. Now, so how do you define an acceleration? An acceleration is defined as, if it is the centripetal acceleration, AC is defined as nothing but change in velocity per unit change in time, okay, if this is a vector quantity, okay. And so here, if we divide this side by here, and both numerator and denominator by change in t, if we divide both numerator and denominator by this small change in t, then change in V by change in t divided by change in R by change in t is equal to V by R, okay. Change in V by change in t is nothing but the centripetal acceleration, magnitude of the centripetal acceleration, and change in R by change in t, the rate of change of this distance, this arc per unit time, is nothing but the velocity again, okay, velocity of this particle. So here in this situation, this centripetal acceleration that we are getting is V square by R, okay. So this is the formula for the centripetal acceleration. So let us take one case, okay. In this case, what we have is, we have a rope, and in that rope there is a ball. In that rope there is a ball that is tied. Now this rope is fixed at this point, and it is getting reeled in this circular path, okay. So in this case, to maintain the circular path, there is a centripetal force. So the tension force that is acting towards the center, okay, this is a rope. This rope is trying to pull this object towards this center, and this tension force is the force that is causing the centripetal force, okay. Centripetal force, and force is nothing but mass into the centripetal acceleration, which is equal to mass into the centripetal acceleration is V square by R. If this was rotating with an angular velocity of omega, then you can write V can be written as omega R, okay, omega R whole square by R. So this tension force is coming out to be m omega square R. So in this way you can explain this case when the object is getting reeled around this circular path and tied to a rope. So in this case, first case, we have taken the observer to be on the inertial frame of reference. He's in the inertial frame of reference and is observing this situation. So he can say that this tension force is the force that is causing the centripetal acceleration. But let us suppose there is another case where the observer is kept not on the inertial frame of reference but is in the non-inertial frame of reference. He is standing here. The observer is standing on the object itself and observing this phenomenon to be occurring. Same, this case also is moving with this rope is getting reeled with an angular velocity of omega, but the observer is here. He is himself moving with this object, so to him he will feel that this object is like stationary. He is in the accelerated frame of reference. He is in non-inertial frame of reference. So how we can explain this case by using physics? What we can do is we can take a pseudo force concept. Okay. Similar to the first, tension force is acting towards the center, but we cannot say that the tension force is causing the centripetal acceleration, because for him this object is like stationary. So you have to take the concept of pseudo force and say that there is a pseudo force whose magnitude is also equal to m omega square r is acting on this object, and which is balancing the tension force that is acting towards the center. So this force that we have introduced is nothing but the centrifugal force. Okay. So centrifugal force is similar to the centripetal force, but it is a pseudo force. It is an imaginary force that we have introduced in order to make the law of nature hold true in case when we are standing on the non-inertial frame of reference and observing this phenomenon. So I will be discussing this problem. In this problem we have been given a cylindrical vessel which is rotating with an angular velocity of omega. Inside this cylindrical vessel we have a man which is stuck to this wall. Now we are supposed to find the minimum speed of this cylindrical vessel required to let the man stick to his position, to this position. He should not fall down. We need to find that angular velocity. We have also been given that this surface of the cylindrical vessel is rough with a coefficient of friction of mu. Now, how we can proceed with this problem? This cylindrical vessel is rotating about this axis, that is AA dash. Okay. Now we can use two methods to solve this problem. First is the method in which the observer is on the inertial frame of reference. So in the first method, the observer is on the inertial frame of reference, and what we can do is the wall of this cylindrical vessel will exert a normal reaction to the person. We know that there is a normal reaction acting on this person, due to this wall, as well as his weight is acting in the downward direction. So we can say that due to this roughness, that is, of this cylindrical vessel, there is a frictional force that is acting upward, because the person will try to fall downward. So in that case, the frictional force will act in the upward direction, okay, which is nothing but mu n. Now the observer in the inertial frame of reference will say that this normal reaction is equal to the centripetal force that is experienced by this person, okay, which is given by nothing but m omega square r. If the radius of this cylinder is r, then this is the equation that we get for the centripetal force. Also, you can see that this frictional force is equal to the weight of this person. So mu n is equal to mass into gravity, okay. So we are supposed to find the minimum speed. So by using these two equations, this equation 1 and equation 2, what we can do is we can simply divide equation 1 by equation 2. What we will get is n by mu n is equal to m omega square r by mg. So here what we are getting is omega square is equal to g by mu r. So you can see that this omega is coming out to be root g by mu r. So this is the speed required such that the person will not fall down. It will stay in its initial position. So we can use the second method to solve this problem. In the second method, we will use the concept of pseudo force, or in the case where the observer is on the non-inertial frame of reference. Say for example, the observer is he himself. So in that case, he will feel when this vessel is rotating, you will feel as if he is stationary. So how we can put the concept of equilibrium? In that case, what we will do is that we'll use the concept of pseudo force. What we can do is that the person will experience the normal reaction force, we know that, and there is a pseudo force that is developed, okay, which is the centrifugal acceleration, that is m omega square r acting, which is balancing this normal reaction force. So we can write n equal to m omega square r, and similar to the previous case, the frictional force will balance the normal reaction, the weight of the person. So we are getting the same equation in this case also. So mu n will be equal to mg. So you can use the same concept in this situation to find the value of omega, and you will get omega is equal to g by mu r. Okay, thank you.